Hello everyone, good afternoon. I hope you did your job last week. I hope you answered all the practice problems that I left you. So I already gave you the answers for practice problems 1 and 2 last Sunday. So I'll be sharing today my answers for problems 3 to 8. Actually, I was recording a while ago while I was answering, but it was not recorded. So I'll just share the answer without the explanation. Now you can see the solutions for the problems. So this is for problem number 3. The centroid is 17 over 5 3/4 using vertical rectangles. I also did the solution for the same problem. I got the same answer, but this time I used horizontal rectangles. The centroid is 17 over 5 3/4. For problem number 4, I also did the two techniques, the two methods. First, using vertical rectangle. I got the centroid 1 3, so it's this point here. Okay, I also tried to solve it using horizontal rectangles, which worked also. The centroid is the same 1 3, of course. This is the centroid of this region 1 3. Okay, problem number 5, using vertical rectangles as illustrated here. I got the centroid 27 over 20 9/4. So it's referring to this point here. I did also this problem using horizontal rectangles as shown in the figure. I got the same answer, 27 over 20 9/4. Problem number 6. So just pause the video so you can follow through the solution. Using vertical rectangles, I got 16 over 15 and 32 over 21. That's this point here. Using horizontal rectangles, the same problem number 6, as you can see as illustrated. Horizontal rectangles, so that's right minus left function. That's when you find the mass. I got 16 over 15, 32 over 21. So the same with what I got using vertical rectangles. Now, problem number 17, I started by looking at it using vertical rectangles. So I draw here a vertical rectangle. So our integration is in terms of x. For the mass, it's linear density times the area. So the area is the upper function u of x minus lower function L of x. So plugging it in here, integrating, I got the mass. I also look for the moment with respect to y, moment with respect to x. So the centroid is 16 over 15, 8 over 21. Using horizontal rectangles, so integration is in terms of y. It's right function r of y minus the left function L of y. Still, we get the same answer. It's 16 over 15 for the x-coordinate of the centroid and 8 over 21 for the y-coordinate of the centroid, referring to this point here. Okay, last item. So using vertical rectangles, as I have drawn here in the graph, so our integration is in terms of x. That's what I have written here. So the limits of integration is from 0 to 2. That's why I have a 0 to 2 here. Then upper function, so this line here, that's y equal to 5. And the region is bounded below by this curve here. So it's y equal to x squared minus 1. So that's 5 minus x squared plus 1. Integrating, I got 16 over 3 raw. I also looked for the moment with respect to y, moment with respect to x. So the centroid is 3/4 17/5. If you need a detailed explanation, please review part 1 and part 2 of my recorded discussions on centroid of the plane region. So the same item using horizontal rectangle. So integration is in terms of y. So right function minus left function. We still got the same answer, 3/4 17/5. So that's it. I hope you will study well tonight in preparation for our formative assessment 1 tomorrow. See you everyone. Bye.